This video is over lesson 76, volume of prisms and cylinders, and it is for my pre-algebra classes. So ladies and gentlemen, just as we saw in lesson 75, where we discovered the formula for the area of a trapezoid, when it comes to areas and volumes, you need to know your formulas. So the formula for the volume of a prism and a cylinder actually turns out to be the same thing. So V equals BH. Now again, a reminder to what we've talked about previously. Remember that capital letters in formulas often indicate that this is something that would be calculated, whereas lowercase letters often indicate something that you could go out and actually measure with a ruler in some way, shape, or form. So when I see a capital B here, this should be a hint that this is going to be something that we calculate, and sure enough it is. So capital B here is the area of the base of the prism or cylinder. So if it's a cylinder, it'll just be the area of the circle, that's the base. If it's a prism, it'll be the area of whatever polygon forms the base. The height then, or h is the height of the prism or cylinder, and it's the perpendicular measurement to both bases. So as we talked about in lesson 75, remember we need perpendicular measures to find area. Well, when you move up to volume, to 3 dimensions, you need a third perpendicular measure. So here we go. We're going to take a look at an example, and we're going to start actually with a triangle. And then I'm going to take this triangle and I'm going to go a little bit out there, and we're going to make a triangular prism. So from here, I'm going to redraw my triangle. Only thing though is this side right here would be invisible. So instead of drawing him as a solid line, I'm going to draw him as a dashed line. And I'm going to go ahead and connect those and connect those. And there is my triangular prism. Now, in order to find the volume, we have to calculate the base, the area of the base, and then multiply that with the height. So the first thing that I'm going to be interested in here actually is going to be capital B. Capital B is the first thing I'm going to be interested in. And so since the base is a triangle, the area of a triangle is 1/2 BH. Now this is where things can get a little confusing. We've got to keep track of which formula we're looking at. So this right here all has to do with the area of the base. So the area of the triangle in this case. So therefore this B, this lowercase b here, and this h here, these are both going to be from the triangle, or triangular base. So it's going to be the base of the triangle and the height of the triangle, and times 1/2. That's what we're looking for here. So we need some measurements. I'm going to go ahead and tell you that connecting here to there would be 6 feet. Along the top, we'll call that 12 feet. And then along this bottom right here, we'll call that 7 feet. So for my triangle, of course, if this is 7 feet here, then this is 7 feet there. So for my triangle, base equals 1/2 times, if that's 7 feet, then that's a 7-foot base as well. So 7 feet times, and then perpendicular height is 6 feet. Put that all together, and we have our capital B, the area of the base. So I would do 1/2 of 6 is 3, times 7 is 21, and feet times feet makes square feet. Now I'm not going to circle that because that's not my answer. I want to find the volume. That's just kind of the first step along the way. Now that I have B, we're ready for our volume formula. So volume formula equals capital B times H. Well, I now know that capital B is 21 square feet, and I know H here, this formula is going to be from our volume of a prism formula. So from the prism. So even though H got reused, we got to keep track of what formula does it come from. Does it come from the area of the triangle, and therefore is the height of the triangle, or does it come from the volume of the prism, in which case it is the measurement that connects these two bases, so, which will typically be perpendicular, and it's not marked, but we're going to go ahead and assume it is. So capital B is 21 square feet times the height of the prism is that 12 feet that connects the two bases. And now if we go ahead and multiply 21 times 12, we get 252. And then square feet times feet, well, there's two of them, and then there's another one. That's a total of 3 of them, which should make sense because volume should give us cubic units. So 252 cubic feet is the volume of my triangular prism. So moving on, we can sometimes, though, take this general equation and make specific equations out of them. So we're going to take a look at a cylinder, just a general cylinder here for a second. So to draw a cylinder, I'm going to start with an oval, and then I'm going to take that oval, I'm going to drop it down a few spaces on each side there, and I'm going to draw half of an oval, and then I'm going to do a dashed curve for the back, because that would be invisible, that would be behind the cylinder. So, excuse me, if we want to put our formulas together, we need to start with our volume formula. From here, I know that B is going to be the area of the base there, so the area of the circle. Well, the area of a circle is pi r squared. So we set this almost up like an addition problem. It's not an addition problem, it's a logical problem. So in this logical problem, what we do is, instead of putting a plus sign here, we actually use a triangle of dots. It's usually about the size of a lowercase letter. And that triangle of dots there means therefore. So if this is true and this is true, therefore, what else is true? Well, V must equal, well, if B is this, remember, ladies and gentlemen, that we can always replace something with what it is equal to. So we're going to replace B with pi r squared. So pi r squared, and then after B is H. So what we've just discovered is a specific formula for the volume of a cylinder. So if I know this, we can just go ahead and find the volume of whatever cylinder we come across. So let's say I have a cylinder here. I'm going to come down a few spaces. And let's say I label this, I'm going to go across there and label this 4 inches. And I'm going to label this side over here 10 inches. And so then this time I'm thinking my special formula, V equals pi r squared H. So instead of having to do these in 2 parts, where first I find what capital B is, and then I put that together with V in the formula for volume, I'm just going to do the volume just right away. So volume equals pi, but we're going to replace pi with its traditional approximation, 3.14. So this will be approximately equal to 3.14, and then times the radius squared. So this goes all the way across, which means that it's actually 4 inches. So cut that in half, my radius is 2 inches. And then, like the formula says, we got to square it. Now we do have to use parentheses on this, because remember, we want to group the 2 and the inches together to communicate properly. Next up, I'm going to multiply by my height, which is 10 inches. You could express this using a multiplication dot. You could express this using another set of parentheses. The one thing that I would not do is I would not just put 10 inches next to this because of the exponent. So you know what, I'm going to keep things simple. It's easier just to write a dot than write two parentheses. So I'm going to put a dot in 10 inches. All right, from here, let's go ahead and work this out then. So order of operations would tell me to do my exponent first. So 3.14 times, and now 2 inches times itself is 4 square inches, and then times the 10 inches that was at the end. Now remember, ladies and gentlemen, we do use an equal sign when we go across like this because we consider how is this related to this? Well, because we replace the pi symbol with what it's approximately equal to, that's why it's approximately equal to. But how is this related to that? It is exactly equal. Now it's all multiplication, so I'm going to go ahead and finish it off. Now since I'm coming down here, I am going to match whatever I line up with. So since this is approximately equal to, that'll be approximately equal to. Because remember, it's a v that's assumed to be here. So v will be approximately equal to anything over here. So 3.14 times 4 is 12.56. Times 10, we'll move that decimal. So 225.6. And now square inches times inches will make cubic inches. And there's my cylinder. All right, we're going to keep moving forward here. Next up, we're going to take a look at a rectangular prism. Now, your rectangular prism is really your typical box. I know some boxes can be shaped differently, but this is kind of your standard box, is a rectangular prism. So we're going to draw this one. I'm going to just start with a rectangle on the front. And then it's just easiest if we drew 3 little diagonal lines about the same length, same direction, and then connect the edges. So there's my rectangular prism. So we know the volume of a prism is capital V equals capital B H. We also know that the base here is going to be a rectangle. So the area of the rectangle equals length times width. So therefore, if I replace B with LW, then V will equal LWH. And we just discovered the formula that you guys already knew. So we've done this enough times, we're going to skip doing an example over that. As a small extension of this then, if we take a look at a cube, so in a cube, each edge is the same length. So we start with a square instead of a rectangle. So in this case, we know a cube is a rectangular prism, just where all the sides are the same length. So what I'm going to do here is I'm actually going to go V equals LWH, and then I'm going to say L equals W equals H. And since they're all the same, we'll say that they're just equal to S. So therefore, we get a special formula for the volume of a cube. Volume of a cube will equal, well, L will turn into S, so that'll be S. W will turn into S, so there's another S, and H will turn into S. So SSS, or S cubed. And so hopefully you can see that these formulas, these special formulas, actually come from this formula up here. All right, ladies and gentlemen, we're going to do one more. We're going to flip over the back here. And this one's going to be a little more irregular. So what I'm going to do is I'm going to start with the beginnings of a rectangle. But I'm not going to finish it off, because what I'm going to do is I'm going to make a barn. So there's my barn. And I'm going to say that this is 30 feet down here. I'm going to say that this edge right here is 12 feet. I'm going to say from here to the bottom, very top of the peak to the bottom, draw a little line there to show that we're going from level with that to level with that. I'm going to say that that's 16 feet. And then to make my barn, I'm going to come out here a ways. And do just the best I can to try to get that all nice and even, looking about the same sizes. I'm not an artist. I don't expect you to be an artist. Just do your best. Things are a little too wonky. Use your eraser. And we're going to say that this ridge here on top goes back about 40 feet. So what is the volume of my barn? So ladies and gentlemen, on this one, we have an irregular face, a regular base to our prism, because the barn here is shaped like a prism. So it can be helpful when you're working this out to just redraw that shape and work out all your measurements. So we don't have a formula for the area of this pentagon. What we can do instead is we can cut this. So I know that this is 30 feet. I know that this is 12 feet. And I know from the very top to the very bottom is 16 feet. So therefore, in my triangle, this must be 4 feet. So the 12 feet plus that 4 feet gives me my total 16 feet. So if we break this apart, first I want to know what the area of my base is. So in other words, what is the area of this pentagon? Well, this pentagon is broken up into two pieces. It's a rectangle and it's a triangle. So the rectangle is just going to be the length times the width. And then if I add on the triangle will be 1/2 base times height. Now remember, this is the length and width then of the rectangle. This is the base and height of the triangle. So if I put this together, B equals the length of my rectangle is 30 feet. The height of my, or excuse me, the width of my rectangle is 12 feet plus 1/2. The base of my triangle, well, if that's 30 feet, then the top of the rectangle is 30 feet as well. And then times the height of the triangle. The height of the triangle is that 4 feet there. So start working this out. 30 times 12, that's like 3 times 12 with an extra 0. So 360 square feet. Over here, I would probably do half of 4 is 2, because then timesing by 2 is real easy. That just turns that into 60 square feet. And it's good that these are both square feet, because in order to add, we need the units to be the same. So we can add these up. 360 plus 60 is 420 square feet. So that's the area of my base. So volume then requires me to take that capital B and multiply it by the height of the prism. So remember, the height of the prism is going to connect the two bases. So in other words, it's going to connect the front of this to the back of it. So V equals, capital B is 420 square feet. And then the measurement that connects the height of the prism, that connects the two, is that 40 feet. So if we multiply this together, we get 16,800, and then feet and feet times feet gives me a total of cubic feet. So there are 16,800 cubic feet inside of my barn. And that, ladies and gentlemen, is our lesson.